In this video, we're going to talk about the chain rule. The chain rule is a technique for taking a derivative, which is going to greatly expand the number of functions for which you can take the derivative. So first, we need to start talking about composite functions. Function m is a composite of the functions f and g if m of x equals f of g of x. So basically, wherever we see an x in the function f, we're going to plug in g. The domain of m is the set of all numbers such that x is in the domain of g and g of x is in the domain of f. So let's do an example. Let f of x equals e to the x and g of x equals negative 3x, and we want to find f of g of x and g of f of x. So f of g of x is equal to e to the g of x, which is e to the negative 3x. G of f of x is equal to negative 3 f of x equals negative 3 e to the x. So g of f of x and f of g of x are different functions. Now we're going to write these functions as composite of two functions. There's not a unique composite, but when we're thinking about the chain rule, there'll be a good way to do this, and sometimes there'll be not a great way to do it. So we'll talk about that later. So I've got an outer function f and an inner function g. So I'm going to write my inner function is equal to 0.04x, and my outer function is equal to 100 e to the x. And we can see f of g of x equals 100 e to the g of x equals 100 e to the 0.04x. So you can see how we put this function together. Y equals the square root of 4 minus x squared. Well, my inner function here pretty naturally is 4 minus x squared. My outer function is the square root of x. And we can see f of g of x is equal to the square root of g of x equals the square root of 4 minus x squared. Now, there are often multiple ways of choosing the inner and outer functions, f of x and g of x. So let me just write a different solution to the second problem. Let's let g of x equals the inner function equal x squared, and f of x equals the square root of 4 minus x. And we can see f of g of x equals the square root of 4 minus g of x, which is equal to the square root of 4 minus x squared. So both of these sets of functions work. Now, one of the rules we're going to use when we're thinking about the chain rule is we want to choose an outer function for which we can take the derivative. So if we're looking at these two, this solution is better for our purposes than this one, because here we know how to take the derivative of the square root of x, but we don't know how to take the derivative of the square root of 4 minus x. So we would end up with having to do more work. So what is the derivative? And this is going to motivate the chain rule. What is the derivative of x squared plus 3x squared? So off first bat, without the chain rule, we don't know how to do this, but we can rewrite our function. We want to take the derivative, but now we're going to take the derivative of x squared plus 3x times x squared plus 3x, right? We're just taking this thing squared and we're writing it out carefully. This is just a product rule. Take the derivative of the first function, 2x plus 3, times the second function, x squared plus 3x, plus the first function, x squared plus 3x, times the derivative of the second function, 2x plus 3. These terms are identical, so we've got two of them. We have 2 times x squared plus 3x times 2x plus 3. And what you'll notice is this is the derivative of the function x squared plus 3x, kind of our inner function. And this looks a little bit like the derivative of the outer function, right? If the outer function here were x squared, the derivative of that is 2x to the power of 1. Now the chain rule, if we have a composite function, y equals f of g of x, then its derivative is the derivative of the outside function, f prime, applied to the inside function, g of x, times the derivative of the inside function. So f prime of g of x times g prime of x, which is why we'd really like to be able to take the derivative of this outer function. Now we're on to examples. So let's find the derivative. Y equals x to the fifth. We've done this, right? For y equals x to the fifth, y prime equals 5x to the fourth, right? That's just the power rule. So that's an easy one. We just wanted to start. Y equals 2x to the fifth. Well, the inner function is probably 2x. G of x equals 2x. The outer function is x to the fifth. Now, I'm just going to be really careful and write everything down. The derivative of the inner function is 2. The derivative of the outer function we've already looked at is 5x to the fourth. I'll write up our chain rule up here. If y equals f of g of x, then y prime equals derivative of the outer function applied to the inner times the derivative of the inner function. Okay. Using our chain rule. Derivative of the outer function, 5x to the fourth, but we're going to apply it to the inner function. So that's 5 times 2x to the fourth times derivative of the inner function, 2. Next problem. Y equals 2x cubed to the fifth. G of x equals 2x cubed. G prime of x equals 6x squared. The outer function is the same. It's still x to the fifth. Derivative of that is 5x to the fourth. The derivative of our function is 5, 2x cubed to the fourth times 6x squared. So, our chain rule. If we have a function y equals f of g of x, then y prime equals the derivative of the outside function, f prime applied to g of x, times g prime of x. Let's do some more examples. Y equals 2x plus 1 to the power 5. Well, the inner function is 2x plus 1. The derivative of the inner function is 2. So the derivative of this is 5, 2x plus 1 to the fourth times 2. E to the x to the fifth. Inner function is e to the x. The derivative of the inner function is e to the x. So the derivative of this is 5 e to the x to the fourth times e to the x. Y equals natural log of x to the fifth. Inner function is the natural log of x. The derivative of the inner function is 1 over x. So the derivative here is 5 natural log x to the fourth times 1 over x. Hopefully this is starting to make some sense now. All right, some more derivatives. 3x plus 1 to the fourth. I'm using f of x over here, so I probably shouldn't use it again. So I'm going to call them inner and outer. So let's call the outer function is x to the fourth. The inner function is 3x plus 1. The derivative of the outer function is 4x cubed. The derivative of the inner function is 3. The derivative of our function is 4, 3x plus 1 cubed, right? We're just plugging in the inner function into our derivative, times 3. X squared plus 3x plus 5 cubed. All right, the outer function is x cubed, the inner function is x squared plus 3x plus 5. I'm going to do it without writing out the details. So 3x squared plus 3x plus 5 squared, that's the power rule, times 2x plus 3, derivative of the inner function. F of x equals 1 divided by x squared plus x plus 4 cubed. Let's rewrite this. X squared plus x plus 4 to the minus 3. Take the derivative. The outer function is x to the negative 3, so that's going to be negative 3. X squared plus x plus 4 to the negative 4 times 2x plus 1. right? We just have to figure out our outer function and our inner function and take derivatives appropriately. All right, one more set. Natural log x squared plus 2x minus 4. All right, the outer function is the natural log of x. The inner function is x squared plus 2x plus 4, minus 4, sorry, minus 4. Okay, our derivative is 1 divided by x squared plus 2x minus 4 times 2x plus 2. Next problem. PV equals 10,000 e to the negative 0.04 t. All right, the outer function, we want to be able to take the derivative, so I'm choosing 10,000 e to the t, because I know how to take that derivative. The inner function then is negative 0.04 t. So the derivative here is 10,000 e to the inner function, negative 0.04 t, times the derivative of the inner function, negative 0.04. And the last one, e to the 4x cubed plus 3x plus 1, the outer function's e to the x. The derivative of e to the x is e to the x, so that's e to the 4x cubed plus 3x plus 1. The inner function is 4x cubed plus 3x plus 1, so we're multiplying by 12x squared plus 3. Remembering the parentheses, you can see it here, you can see it in this first one. Remember the parentheses is really important. And again, writing it out, y equals f of g of x, y prime equals derivative of the outer function applied to the inner function times the derivative of the inner function. So that's our chain rule. Again, the way you learn these things is practice. Lots and lots of problems. I've done lots of problems here, and there's lots of problems in your homework, and it's just a matter of practice in order to get the hang of it.